So the first thing today, we start with the alcohols. Now, most of the nomenclature, that means naming for alcohols, we already know, but just a quick review because it is given in the specification. So when you talk about alcohols, the general formula is CnH2n plus 2 plus 1 OH. Now, how are we getting this? We are getting it from alkanes. Alkanes have a general formula of CnH2n plus 2. So what we are doing is we are removing one of the H atoms. This is removed. So when you remove it, you get the formula as CnH2n plus 1. This 2, you remove the 1, and in its place, you bring the OH. And that leads to your general formula, this thing. So this is the general formula. They belong to the family of, or they are named as alkanol. And the word alcohol is a name of a homologous series. Is a name of a homologous series. So they are named as alkanol, where alk represents the number of carbon atoms. Represents the number of carbon atoms. In this represents the carbon-carbon single bond, and the all that represents the functional group. That represents the functional group. Now, for the functional group, for alcohols, the functional group is OH, but they may ask you the name. They may ask you the name for this. Remember, the name for this is hydroxyl group. There's another thing that is OH minus. The OH minus is called as a hydroxide ion. So these two are totally different things. These two are totally different things. So the next thing is just a quick review for the naming. Let's say I give you this thing, CH3OH. Now there's one carbon atom. So for one carbon atom, it should have been methane. But there is a functional group over here. So you will remove the E, and in that case, you will write all. So this becomes methanol. If you have, let us say CH3, CH2, OH, same way, there are two carbon atoms. So for that, you will write H. There is a single bond between them and the OH. This was a simple thing. But let's say if there are more branches and all that, for example, let's say you have a OH over here, and then you have a CH3 over here, and this thing. Now, for the naming, the rule is that if functional group is present, if functional group is present, then if the functional group is present, then it has to be part of the parent chain. It has to be part of the parent chain. Okay, and it has to be the part of the parent chain. Now, what does that mean? Now, the problem with the OH is, OH does not contain the carbon. That's one thing. And when you talk about parent chain, the parent chain is made up of carbon atoms only. So in this case, we will focus on the carbon that contains the OH. So this carbon which contains the OH needs to be the part of the parent chain. That is one thing. So right now, we can take this as a parent chain, either this one, or you can take even this one. You will end up with the same name. In both the cases, the carbon that carries the OH, that is a functional group, it is a part of the parent chain. That's one thing. The second thing is the functional group. This is a rule for the naming. The functional group should get the minimum possible number. Now you have done in your IGs that right now I'm just looking into the OH, that the OH has a higher preference than the C double bond C, and this has a higher preference than the substituent. So here the OH, I'm treating it, or it is a functional group, but I'm specifying it in terms of the OH. If this was any other functional group, then it will also be has a more preference than C double bond C. But if there's more than one functional group, then there is a different rule. Then there is a preference table, which right now we don't need to know that. So in this case, your molecule has two ways of naming, numbering. One way of numbering is from left to right, 1, 2, 3, 4. The other way of numbering is 1, 2, 3, 4. But we know that the functional group should get the minimum possible number. Now again, the numbering is done for the carbon atoms of the parent chain. Now in alcohol, there is no carbon atom, so we are focusing on the carbon that carries the OH. So according to this rule, this is getting 2 over here, this is getting 3, so this is a lower number, so you will prefer this numbering, not this numbering. So finally, we have come to the conclusion that if this is your molecule, then the first thing is this is your parent chain. The second thing is the correct numbering is this, following the rules, and then you start writing down the name. Now, according to the systematic naming, we do the systematic naming or the IUPAC. That means according to the rules, what is going to happen? The first thing is you need to write down the substituent. So this is your substituent. This is your substituent. So you need to write down its position. Position is 3. Name of the substituent is methyl because of one carbon atom. Then you write down the name on the basis of number of carbon atoms in the parent chain. So there are 4 of them, but, all are single bond, ane, and then you write down the position of the OH. So this will be the name of this alcohol. Let's try another one. If you have this over here, like this. So this is an easier one. You have this as a parent chain. You can take many other also, but you will still end up, you could have taken this also, you could have taken this also, no problem. Now you will get back to the numbering. So numbering is 1, 2, 3. So this will be 2-methyl propane because of 3 carbon atom and 2-all. So if it is position O, first position, you don't need to write down. Like for example, when we were talking about here, when we were talking about this place, this is the first position, 1, 2. So you don't need to write that. If you write it is not wrong, it won't be considered as wrong. Like if you write it as ethane 1-all, it is okay. But when it is first position, there is no need to write. Otherwise, you will have to write down the position. Now coming to, so naming is done. Now coming back to the classification, or before classification, you can have alcohols or the OH attached differently. Like you could have, let us say the way we are talking about this CH3OH or CH3CH2OH. So this could be straight, like the one I've shown you, or they could be branched. That does not matter. Branched means the ones we have taken like this. That does not matter. They are considered as aliphatic alcohols or simply the alcohols. So this is what we are going to deal with now in this topic, aliphatic alcohols. Then there is a possibility, you will study these kind of thing at the A2 level, that there is a benzene. This is called as a benzene ring. Right now, no need to worry about the exact structure. In this case, there is a possibility that the OH is directly attached or to the benzene ring, or the OH is attached to the side chain. There are two possibilities. Now, if it is attached to this benzene ring through the side chain, it will be considered as a aromatic alcohol. It will be considered as an aromatic alcohol. That means it shows a different nature basically. And if the OH is directly attached to the benzene, it is not called as an alcohol, it is called as a phenol. So this is a different group of compounds. Right now, this part, we don't need to worry about. This is A2. We need to only focus on aliphatic. So next thing is the classification of aliphatic. So when I'm talking about alcohols, remember we are talking about aliphatic alcohols, classification of alcohols. Now this is based on the structure, based on the structure and position of OH and the position of the OH group. So there are three kinds: primary, secondary, and tertiary alcohol. Very important. There is a slight differences between the reactions also. Primary is represented by 1 degree, this is 2 degree, this is 3 degree, or you show it by prime dot, sec dot, and tertiary dot. So let's understand the difference. When you talk about primary, primary is alcohol basically, yes. So primary alcohols are when the carbon carrying the OH group, carbon carrying the OH group is directly attached to one carbon or none. It is similar to your haloalkanes or carbocations. So for example, you have OH attached over here and you have the H over here. So our focus is this carbon because it carries the OH. It is not directly attached to any of the carbon atom. So this will be considered as a primary. However, if it was like this, now your focus will be this carbon atom because this carries the OH. Now in this case, it is directly attached to only this carbon. This carbon may be attached to further more carbon atoms, we don't care, directly attached. So the carbon that carries the OH, it is directly attached to one carbon. So this also is a primary alcohol. Now, if you go to secondary, they have asked in the exam the meaning of primary or secondary. So this is what you will be writing. So secondary alcohols, similar thing, carbon carrying the OH group is directly attached to two carbon atoms. So remember, it is directly attached. Like in this case, the OH is attached to the carbon, and then this is attached to two more carbon atoms. Two more carbon atoms. Now they are attached to what other things we don't care. The important thing is that it is attached, this carbon, it is attached to one more carbon atom and another carbon. Finish. It is attached to two carbon atoms. This is what we said. So this is secondary. This in turn may be attached to more carbon atom. This may in turn be attached to more carbon atoms. We don't care. We are talking about the direct attachment. And then the tertiary alcohols. In this case, the carbon carrying the OH is directly attached to free carbon atoms directly attached to 3 carbon atoms. Just a minute. I think I should, yes. This is aliphatic when it is attached to the side chain. This is aliphatic. So they may ask you questions on this, which is rare, but this will behave as a aliphatic because it is in the side chain. So if the OH is in the side chain of benzene, side chain of benzene, then it behaves like a normal, then it behaves as aliphatic. So it will show you the same reactions we are talking. If it was like this, if it was like this, let us say you have CH3 over here and OH is attached over here. So it is OH again, but this is not a phenol. This is not a phenol. The OH is attached and then there is another CH3. So if the moment the OH is attached to the benzene ring, it is not a normal alcohol. It will be considered as a aromatic alcohol. Again, with the benzene, you don't need to worry anything. You need to focus on this thing. Then the tertiary, yes, I was over here. So it would be like this. And OH. So the carbon that carries the OH group, it is directly attached to 3 carbon atoms. Directly attached to 3 carbon atoms. 1, 2, and 3. So this will be your tertiary alcohol. How will we name them? Let's try to name it. Now you can take this as a parent chain. The OH is the carbon that carries the OH is a part of the parent chain. Then you have to number it 1, 2, 3. So this will be your 2-methyl again. Okay, we have done this example. So this will be propane. You have to write 2 all over here. So this was all about the nomenclature, that is a naming in systematic name, classification of alcohols, and the talk about its functional group and so on. Next move on to the physical properties. Now, when you talk about physical properties, the two main things that we are looking at is the boiling point or the melting points. If it's solid, then it is a melting point, and the solubility in water. These are the two, solubility in water. These are the two things that we will be looking into in terms of the physical properties. Now, when you talk about the boiling points, they depend on the, or both basically, they depend on the type of intermolecular force. So we need to understand what type of intermolecular forces are present in alcohols. So let's focus on the boiling point first. Let's say I have a CH3OH, or let me compare it first of all with for that will give us an idea of the type of, let us say I have alkane, I have alcohol, I have carboxylic acid. You have an idea of carboxylic acid from your IGs. More details are in A2. So alcohols are represented as ROH. R stands for the alkyl group and OH, and the carboxylic acid is C double bond O, OH. And alkanes are just alkanes. That's the basic. Now, if you want to know which of them has a higher boiling points or the order of boiling points, we need to know, or in your exam, you need to talk in terms of the type of intermolecular force. Now, alkanes have only London forces. We have talked about this in the chapter for intermolecular forces. This is only London forces. Here, you have the London force, you have the dipole-dipole interaction, that is a permanent dipole, and you also have the hydrogen bond. You also have the hydrogen. Carboxylic acid has all of these, all of this, but they are all more. More details we have already done in that chapter topic for intermolecular force, so I'm not going to show it over here. So this clearly shows that there are more forces to be broken over here. So the order of boiling point, order of the boiling point would be this way. The carboxylic acid will. So in the exam, if they ask you, you need to talk in terms of the intramolecular force. So this was the comparison of carboxylic acid. This was a comparison of the alcohols with alkanes and carboxylic acid. The next thing is, if we are talking about, let's say, within the family, CH3OH. So this is another comparison now. Now CH3COH, CH3, CH2OH, and then CH3, CH2, CH2OH. Then how can we arrange them in order of boiling point, or because all of them, they will have the same type of intramolecular forces. All of them, they will have the same type of intramolecular forces. But in this case, what happens is, in here, there is the least molecular mass, while in this case, the maximum molecular mass. Why? Because it has only one carbon atom. So that this will lead to maximum surface area, and we know the surface area is related to more van der Waals forces or London forces. And if there are more London forces or van der Waals forces, then you will need more energy to break the interactions, the intramolecular forces, and as a result, therefore, maximum boiling point. So this has a larger surface area because it has a more molecular mass compared to this, and this has a least molecular mass. They will have the hydrogen bond, all those things are there, but because of the surface area, the intermolecular force, which is the van der Waals force, will be maximum in this case. So, so therefore, the tertiary will have, sorry, we are not talking about the tertiary. So this thing, the CH3, CH2, CH2OH will have a higher boiling point compared to ethanol, which is more than methanol. So this is propanol. This is ethanol, and this is methanol. So you can safely say that with increasing molecular mass, the boiling point of alcohols increases. That's the general rule. And you know the reason. The reason is because there is more van der Waals forces due to the larger surface area. Now, if you compare, let us say I have I'm comparing the boiling points of and all of them, they have the 4 carbon atoms, all of the same. So basically these are isomers. All of them, they are isomers, and they have the same molecular mass. as molecular formula is same. Now, in this case, how we will figure out? Because we said before that when the molecular mass is more, then the surface area is more, and so on. But here, the molecular mass is the same. The reason is they're isomers, so they have the same molecular formula. So in this case, the concept we have talked about is greater the branching, the concept that we know is, remember, this is only for isomers. This is not applied other places because other places, if the molecules are different, the molecular mass will be different. So we are talking about isomers where the molecular formula is same, so the molecular mass is same. So greater the branching, smaller the surface area. Smaller the surface area. And if the surface area is less, it means less van der Waals forces or London forces, less van der Waals forces, and as a result, you will have less energy required to break the intermolecular forces, less energy required to break intermolecular forces, and as a result, the boiling points will decrease. The boiling points will decrease. So this is the main concept. Now, if you will go back to the examples, here the OH is attached to a carbon that is attached to 3 other carbons. So this is a tertiary alcohol. This is no, this is I should make it I should make it secondary for comparison. So let's say I attach CH3 over here and H over here. So this way the OH is attached to the carbon, which is attached to 2 other carbons. So this will be secondary, and this is primary. So if you will observe over here, in tertiary, there is more branching. Over here, there is 2 branches, and over here, there is only 1, no branching. So that means in this case, the primary, the order will be, the order of boiling point would be, order of boiling point will be, primary will be maximum, then comes the secondary, and then comes the tertiary. The reason is they have the greater branching. They have more branching, while this has the least branching. So this was all about your, this is all about the boiling point. Now moving on to solubility. Now remember, when you're talking about solubility, we need to talk about the intermolecular force with the water molecules. Now alcohols are soluble. Alcohols are soluble in water. And the reason is due to H bonding, that is a hydrogen bonding, which is a type of intermolecular force with water molecule, with the water molecule. So if you want to show it, let us say this is one of the alcohol, any alcohol like this. This will be partially negative, this is partially positive, and then you have the water molecule. So water molecule also partially positive, and this is negative. So this will have the hydrogen bond over here. This will have a hydrogen bond over here. I hope it is clear. So we are talking about this thing. So alcohols, they dissolve in water. Now again, if you are comparing CH3OH, CH3CH2OH, and CH3CH2CH2OH. Now here what happens is the solubility of alcohols, and this is the same thing also for the carboxylic acid. The solubility of alcohols decreases with increasing molecular mass. And the reason for this is, the non-polar alkyl group, which is not involved in hydrogen bonding, gets bigger or larger. Therefore, percentage hydrogen bond becomes less or weak. What does that mean? Like if you look over here, this CH3OH, it's approximately 50% of the molecule is involved in the hydrogen bond. But when you go to ethanol, it is only 1/3, because this is one alkyl group, this is another alkyl group. So it is only 1/3 of the molecule that is involved in the hydrogen bond. So definitely it will be weaker. This is a non-polar part. This is a non-polar part and it is not involved in the hydrogen bond. And then if you go to this one, that is propanol, then what happens? It is only 1/4 of the bond, the molecule, because there are 3 alkyl groups over here. So these are non-polar part, not involved in the hydrogen bond. So this is 1/4 of the molecule only involved in the hydrogen bond. So as the molecule becomes bigger, what happens is the percentage of particles or the atoms involved in the hydrogen bond is decreasing. So if the hydrogen bond is decreasing, the solubility will decrease. So for your exam, this is what you need to write down. So at the end, we can say that methanol will be more soluble, order of solubility, then ethanol, and then propanol. So you can say solubility of alcohol decreases within a, or just say with increase in molecular mass, with increase in molecular mass. Finish. So this is all about your naming, nomenclature, uh, uh, physical properties. Next, we will talk about reactions involved in alcohols and oils. So the introductory part is done.